Everyone, welcome to module 4 part 4. So in this part we are going to discuss the topic frequency limitation factors and cutoff frequency. Basically there are two types of frequency limiting factors in JFET. One is the transient capacitance. First one is the transient time, and second one is the capacitance charging. So these are the two frequency limiting factors, the transient time and the capacitance charging. First we'll discuss the transient time. Transient time is given by tau t equals to L by Vs, where L is the length of the channel and Vs is the saturation voltage. So tau t equals to L by Vs, where L is the length of the channel and Vs is the saturation voltage. Now Vs for silicon we have different values. For germanium we have a different value, the saturation velocity, and for silicon we have the saturation velocity as 1 into 10 raised to 7 centimeters per second, and Vs for germanium is 1.2 into 10 raised to 7 cms per second. This is helpful while doing the problems. So the saturation velocity for silicon is 1 into 10 raised to 7 and for germanium is 1.2 into 10 raised to 7 centimeters per second. So this is the limiting factor only in high frequency devices. Next we'll check the charging capacitance. So this is the next frequency limiting factor. Now consider the equivalent circuit over here. So this includes the capacitance and the diffusion resistance, and this includes capacitance and the diffusion resistance is ignored in this. CGS and CGD are the capacitances. So the output current will be short circuit current over here. So that is the ID current. As the frequency of the input signal voltage VGS increases, so this is the VGS over here. As the frequency of the input signal voltage VGS increases, the impedance of CGD and CGS decreases. Hence the current through the CGD increases. For a constant GM VGS, the IDS current decreases. So that is the drain to source current, it decreases. If the capacitance charging time is the limiting factor, then the cutoff frequency Ft is defined as the frequency at which the magnitude of the input current II is equal to the magnitude of the ideal output current GM-VGS of the intrinsic transistor. The output is short circuited, hence II equals to II is equal to So II equals to j omega into CGS plus CGD. into VGS. Now, if CG is equal to CGS plus CGD, then the cutoff frequency II will be equal to 2 pi ft. This is the cutoff frequency Cg into VGS. So this is equal to Gm VGS, or the cutoff frequency Ft is equal to Gm by 2 pi Cg. So this is the cutoff frequency. Now the maximum possible transconductance. The maximum possible transconductance Gm is maximum equals to GO1, which is equal to E mu n Nd Wa divided by L, and the minimum gate capacitance is Cg minimum equals to epsilon S WL divided by A, where A is the maximum space charge width. A over here is the maximum space charge width. The maximum cutoff frequency can be written as Ft equals to E mu n Nd A square divided by 2 pi epsilon S L square. So this is the maximum cutoff frequency.